um, research fellow. And I had the privilege to be Shuba's primary supervisor. It has been wonderful to watch Shuba grow and claim his many, many successes, including that sliding doors moment of the Wellcome Trust Fellowship in 2018. You will hear Shuba's recent exciting journey as we go on, but I wanted to just add my personal note. Shuba is recognized for his wonderful smile, his keen badminton prowess, his calm demeanor, and his huge devotion to his family. And I just want to wish you so many congratulations, Shuba, on your wonderful journey, and we're looking forward to hearing about it.
Thank you, Nikki, and thank you everyone for coming on a cold, wintry evening. I'm going to share some of my journeys over the years, some research, some personal things. And first of all, it's great to be back here. What I mean that I came to this room almost 15 years ago to present my first ever research project. And that's with Toppen, and I'm glad Toppen is here today. And we were discussing some optical imaging and EEG together in newborn infants. Now, Toppen couldn't attend that meeting with me. At that time, coming to Neonatal Society was a little bit scary. What I heard about different groups and tough questions. But anyway, someone kindly came in from UCL to support me, and Judith is now sitting on the back. And that was my first meeting with Judith. And over the years, she has been a real support for me. And thank you, Toppen, for introducing me to the world of NEARS. So this is what we were doing at that time. And I'm glad to find some of those old slides. So we were trying to monitor extreme preterm babies with EEG and optics together. Of course, the idea was to see some of the seizures, if we can pick up, and what those seizures mean in terms of hemodynamics. But unfortunately, we didn't manage to pick up any seizures. But what we picked up, the postictal periods, so after seizures, and we could see that there were some transient, repetitive hemodynamic events happening in the brain on the injured side. So these 3 babies that we have looked out of 4 babies had perinatal stroke. And you could see on the image, on the imaging, that there was a clear MCA stroke, and we could see these repetitive changes. But we were not entirely sure what these changes actually mean, because we didn't have any EEG-specific correlate. There was some suppression of the EEG. We thought there might be some immature cortical depolarizations, but the jury is not out yet. I'm going to talk a lot about lights. So it's better to clarify what is invisible and what is visible, right? So invisible spectrum ends and the invisibility starts. And here in the arrow, you can see between around 650 to 1000 nanometers is the near-infrared spectrum. And that's all we are going to talk about today. I'm pretty sure most of you have been there. It took me almost 30 minutes to take this picture in a cold wintry evening because I wanted nobody to be present except this glass house, but still someone managed to creep in. The reason I am brought back that picture is because of this painting. This is probably the first documentation that the light can penetrate through your tissue. So if you can look at the fingers against the candlelight, you will see clearly the artists have documented that. And what we see in everyday life in our neonatal intensive care unit, this is a SATS probe in a extreme premature babies. And clearly light is traversing through the tissues. So with the near-infrared spectroscopy, we kind of use that ability of the light to penetrate tissue. And in very simple terms, there are certain pigments in the body which absorbs that light. And then there are clever physicists and engineers who have developed algorithms which we can use to measure the concentration changes of certain chromophores that absorbs light. Now, the easiest one is oxy and deoxyhemoglobin. You only need 2 wavelengths to measure that. And what I learned that in the early days, the clinicians wanted an absolute number. Okay, and that's how the cerebral oxygenation measurement was produced. But we have to be a little bit careful about cerebral oxygenation, what it actually tells. It's not just the oxygenation, it's the balance between delivery and the use. And when we talk about a newborn brain, it's mostly in the venous component. So 75% of what you're measuring comes from the venous component. The rest comes from the mixed tissue. Now, if you have multiple array of source and detectors, you might be able to do some imaging as well. But for today, I'll stick to near-infrared spectroscopy, not the imaging sides. Now, you might also see there is another component here is cytochrome C oxidase, but I'll come back to that later on. So this was my best friend over 2 years when I was doing this research fellowship with Topham in Cambridge. What we're trying to do was measuring optical parameters with Hama maps through 200 NX, and we had a Doppler measurement from here as well. So you can see the Doppler probe there, and then somewhere here hidden is the optics probe. Now, measuring optics over a prolonged period of time, it's not easy. But tell me about measuring continuous Doppler in a preterm baby. It's even more difficult, I can tell you that. So the idea was that we develop an index of autoregulations that might relate to outcomes. And we developed initially 2 indexes. One was TOI, the oxygenations, versus heart rate, a moving correlation coefficient. Similarly, with NCA flow velocity and heart rate. And we demonstrated that unfortunately, these pictures came quite poorly here. I don't know why. But TOHRX actually correlated with the CRIP score quite prominently. But then we also introduced the concept of optimal blood pressure. This came directly from the adult neurosurgical neonates. And during this project, there were 2 people who helped me quite a lot. One was Professor Marek Jasnika and Peter Smielewski from Cambridge Neurosciences. What was it all about? That if you continue to monitor for a reasonable period of time, this is your time here, you can see, and this is your TOI-HRX. So at some point here, when your lowest TOI-HRX you will see, you will find, sorry, it's not the time, it's the blood pressure. And the lowest blood pressure will indicate the most optimal TOI-HRX, which will give you an idea about what you should target. We presented that in ESPR and in PAS next year. And in this ESPR, I met a Greek biomedical engineer from UCL. He was very enthusiastic, came and talked to me about my project. And also I learned some of his work. Little I knew that I will end up with a project with him next year, but I'll come back to that again. So going back in time, I wanted to share where I came from. So I come from a small town by the river Ganges. The town is called Diamond Harbor. In this small town, everybody knows everyone. My mother was a teacher, my father was an engineer, and I have a wonderful brother too. I went to a school called Ramakrishna Mission, Shorisha Ramakrishna Mission. I went back and took this picture just before COVID. And when we were there, this entire period was open. And this was our makeshift cricket pitch. And I was quite sad to see these lovely flowers there. And this mandir is there. It looks nicer nowadays. The students have to walk at least 10 minutes to go to the main field where the proper cricket pitch is there. But it's a loss, I think. From there, I moved to Narendrapur Ramakrishna Missions, and I spent 2 years there. We call it year 11 and year 12, but in this country, it will be year 12 and year 13. And these 2 years actually changed my life. Now, while I was in the school, it was very clear my parents wanted me to be a doctor. There are enough engineers in the family, so we need a doctor. So I then ended up in this medical college. It's a tertiary center, Optical Medical College in Calcutta. And I spent next 7 years here. Then I ended up doing my pediatric postgraduations in this building. This is a recent pictures, but I can tell you it hasn't changed a bit in 20 years. At somewhere here, we had the outpatients. We used to go there at 9 o'clock in the morning. And if you are lucky, you will finish the outpatients around 3 o'clock and you have to see 120 to 140 babies. There is no question about it. You cannot come out of this room unless you finish that number. And if you look at this guard sitting there, his posture, you will see how tired he is. I think he looked after all these people, and this picture was taken in the evening. And then after that, I came to UK. My first post was in LGI, Leeds General Infirmary. And from there, I moved to do an SHO rotations in the Southwest and ended up in the land of Wallace and Gromit in the Bristol Royal Hospital for Children. It was fun working there. And then the last post of that rotation, 2.5-year rotation, was in South Mid Hospital. And in the South Mid Hospital at that point, Professor Andy Whitelaw was running the drift trial. It was quite inspiring to see the whole process. And probably during that period, my interest in neonatology started more and more. Now, from there, I went to Cambridge to do my training, registrar training. I went to Southend Hospital first, spent there 1.5 years, then Luton, and then ultimately ended up in Cambridge. In Cambridge, alongside the routine clinical training, I did 2 years of research fellowship and then 1 year in the leadership and management training in the Judge Business School, and then came to UCLH in September 2012. And the idea was I will learn neonatal neurology a little bit more and then find a consultant job somewhere else, or maybe here. I didn't know that. And you all know this picture. This is one of from Nikki's papers. So this is the primary energy failure and secondary energy failure. And Nikki runs the preclinical neuroprotections lab here. And I had a discussions with Nikki, and Nikki wanted to ask whether I would be interested to do some research here. And I wasn't sure, very honestly. I think my initial answer to Nikki was, I'll have to think about it. And Judith came to my rescue again. She said, go and spend some time in Nikki's lab and see what's happening there, and go and speak to Elias, because Elias is developing a system which can measure cytochrome C oxidase. I said, okay. And then I went and spent a day in Nikki's lab, and I saw this. So as you all know, the NT-EPP is the brain energy state, and following HI, it goes down and then goes up following resuscitation. And this was the first time I was ever actually seeing a cytochrome measurements, and it followed very closely the brain energy state. And I was sold. And that day, I took a decision that, yes, I will go ahead and work on this. And then subsequently, Alan, Elias, and Nikki published this paper in Neuroimage, where it shows that the cytochrome C oxidase actually correlates your brain energy state before, during, and after HI as well. So why we are excited about cytochrome C oxidase? So if you look at this figure, this is the electron transport chain. So electrons have to flow through all the complexes to create an electrochemical gradient between the two sides of the inner mitochondrial membrane, so that the ATP synthase here, this is a rotating enzyme, and then ATP synthase will then produce ATP, from ADP and inorganic phosphate. So if you can measure what's happening in here in the cytochrome C oxidase, we'll be able to get an idea about what's happening in the ATP generation. And if you go back to very original seminal paper of Jobsis, you will see that there was an attempt to measure cytochrome. But the difficulty is the cytochrome amount is very little in the tissue. So it's almost 1/10 of hemoglobin concentration. So to measure cytochrome, you need a lot more wavelengths. For measuring the hemoglobin component, a couple of wavelengths will be fine. So Elias built this machine, and at that point, Gemma Bell was Elias's PhD student who was doing work with me. And we brought this instrument that Gemma built called Cyril. Now, Cyril is a Canadian cartoon character, but we didn't put the name Cyril on the basis of that. This was cytochrome research instrument. And I can tell you, we don't have these cupboards in neonatal intensive care anymore because we don't have any charts anymore. But there is a baby there, and you can see the whole setup, and we were actually monitoring this baby along with a Hamamatsu neuro system as well. Now, if you are monitoring HIE babies, it's pretty sure that you will be able to monitor some babies with the seizures as well. So this was the first baby I monitored with seizure. This was a baby in our ITU1, in bed 1, came from outside, moderate encephalopathy. And I think I can see Christina sitting here. Christina studied this baby for her PhD, and I studied from optics point of view. And this baby did very well subsequently. And if I just go into the next slide, I can tell you what actually was happening. So this was the raw EEG. On the amplitude integrated EEG, you can see this baby had multiple seizures, and the seizures look like this. But in reality, in the optics, we could see that the cytochrome C oxidase going up, the brain oxygenation is going down, and the brain blood volume was going down. And what was interesting for me is the optical signals were actually visible with the changes even before the raw EEG. So this is the first time we could see that that we could understand what the changes were happening in real time with the seizures. Then came another baby. This is again a baby came from a level 2 centers in cot 2. I can still remember. This baby was seizing in the local unit from almost 7 hours of age, and continued to seize up to 17 hours, needed multiple anticonvulsant. By the time the baby came to UCLH, there was no seizures. And while I was actually admitting that baby, I was working on IT1 that day, I was talking to the father, and what he told me actually gave the clue. The seizures were noted in the right upper and lower limb. So by now, you probably understand what I'm talking about. And I monitored this baby for 90 minutes. And then when a couple of days later, I looked at these records, in the first glance, it looked like there's lots of artifact. And then I went back to look at the EEG because we had the video in that EEG, and there was no movement in the baby. So I then went back and started looking at each of these spikes, and then it looked like exactly the same thing that I noticed in Cambridge. So there were these repetitive changes, this time not only in hemodynamics, but also in the metabolic components as well. And ultimately, this was again asymmetry between the hemispheres, and this baby again had a perinatal stroke on the MCO territory. Now, my PhD was primarily on babies with HIE, and I wanted to look at how the autoregulations changes in these babies. Now, in the past, Flora Wong, Topan Judith, and John White together published a paper in pediatrics, and they used frequency domain analysis to look at coherence and gain in preterm babies. And that related to their outcomes. And there are also some time domain analysis available there out by different groups. And I wanted to put both those two together. And I was looking at different options of advanced signal processing. And at the same time, someone working in adult neurointensive care in UCL, David Heighton, published a paper in anesthesia. And he used these wavelet analysis. Now, the beauty of the wavelet analysis, you have the frequency and the time together. So you can present the changes in the frequency and time between the two variables. And these are the kind of couple of examples that I created: a baby with a moderate encephalopathy with a good outcome, with a severe encephalopathy with a poor outcome. And if you can use a color map well, you can easily see what was happening in these two babies. Now, we created an index of cytochrome and blood pressures. We looked at their phase relationship and then tried to find out what was happening with our deep rare matter lactate Na. That's our clinical biomarker. And we could see some relationship there. And when we tried to see what was happening between lactate Na less than 0.3 and more than 0.3, we could see that these biomarkers could actually differentiate them. And then with, I think Roxana Ghani was our pediatric neuroradiologist at that time. And with her, we did some MRI scorings. And again, it seemed like not only with the MRI scoring, but also in the neurodevelopmental outcome. I'm glad Angela is here today. She did all these neurodevelopmental outcomes. So this index with cytochrome and blood pressure semblance actually was working well in HIV babies in terms of their outcome. Now, you might have noticed that we were doing lactate less than 0.3 at that point. That is no more our clinical biomarker anymore. All of the existing biomarkers that was available for predicting outcome before cooling actually changed their sensitivity and specificity following the introduction of the cooling. But we didn't look at what happened with the lactate Na. So Giles, myself, and Nikki actually looked at all our babies since the start of cooling from 2010. And we were delighted to see that it was still very effective biomarker for predicting outcome if we can do that monitoring within the first 14 days. And Alan Bainbridge is here, who suggested to include threonine so that we have a better fit, and we changed the analytic technique to tarquin, which also had a better metabolite assessment. We also had some fun as part of the metabolite group. We went to Royal Society Summer Science Exhibitions in 2019. As you can see, we created a replica of UCLH neonatal unit there. And we also checked whether Anna's brain was working properly. And I can confirm it was absolutely spot on. Now, I was coming at the end of my PhD, and that's not a great time for anyone who is trying to go into academia. You have to secure a fellowship or a large grant for having any chance to go into academia nowadays. And I went back and looked at my PhD, and the neonatal seizures were the most interesting thing for me because that I raised more questions that I could answer during my PhD. And I thought, this is what I should work on. And I was quite lucky to be UCL at that period because there was so much of help available. I spent time with Neil, Howard, of course, Nikki and Elias was there. I also spent some time with Geraldine Wallen and Ronnie Pressler and developed a proposal. So before submission, I wanted to collect some data so that I could convince Wellcome Trust or MRC that yes, there is something that can be done. And the kynic acid came up with one of the first things that we should try to develop or induce seizures. And when I spoke to several groups within UCL, Xavier Gole and some other brain science people, it was clear that if we use kynic acid, there will be so much of movement, the data will be full of artifact. So that plan got cancelled. Then we decided to go for an alpha agonist by Kukulin. I remember that day very clearly. So Adnan, Chris, and myself was in Nikki's lab, and Adnan brought these bicuculin bottle. We looked at the papers. We started with a small dose, no seizures. We doubled the dose, no seizures. At the end of 1 hour, we used the whole bottle. There was no seizure. And I could see my fellowship proposal fading away in front of my eyes, okay? We spoke to Nikki, discussed with Nikki, came back next week, tried again, no seizures. Okay, so stopped everything, went back to all the publications, so nothing mentions, we're doing everything right. So there must be something that we are doing wrong. So we went back to pharmacology books. And in one of those, it says that you have to dilute the biocuculin with hydrochloric acid and then titrate with alkali and then give it so that it can cross the blood-brain barrier. Okay, start again. So went back, more biocuculin, hydrochloric acid, tried. Immediately there was seizures. Okay, and we got some nice stress, which we put into the fellowship applications, and that was a success. Now, trying to be a clinical academic, as I said, it wasn't easy. So time was running out, 3 months left. I sat down with Nikki and Christina, our HR in UCL, that yes, there's no more funding available after 3 months. So I booked a ticket and go to India. And that particular week, I remember I had a meeting with Nikki on Thursday. On Friday, that week, the Wellcome Trust was supposed to come back to me telling the successful candidates whether they were successful or not. So the flight leaves around 9:30. I need to be in the airport at around 6:30. So I waited till 5 o'clock at home. There was no phone call. So I stopped talking to my wife and my daughter, driving steadily towards the airport. 5:35, a phone call came in from Wellcome Trust. And they had some problem in their computer, so they couldn't put the scores together. But anyway, it was a success. And that changed my life. And then a couple of days later, Nikki sent me this from the rest of the team. So we started INSPIRE study. And this was a preclinical study and the clinical study. And at this point, Kelly Harvey-Jones, Kelly came in to do her PhD with us. The idea was that we were going to look at the mitochondrial metabolism, blood flow, oxygen delivery, oxygen utilizations with video EEG, MR imaging, structural perfusion, and spectroscopy, both proton and phosphorus. And we added a diffusion correlation spectroscopy with the broadband NIRS to measure these blood flow. I'm not going to go into all the details, but we created 3 groups in the preclinical study. One was vehicle, then another group received biocuculin and had seizures. Sorry. This is the group. And then the third group where we gave biocuculin, and after 10 minutes of continuous seizures, we gave phenobarbital. And then, of course, all the monitoring were completed. You could see these seizures. This was, I think, around 8 to 9 in the evening, or around 10 o'clock, I think, after the first set of scanning. And then this is around 1 to 2 in the morning with a second set of biocuculin. So there was generalized tonic-clonic seizures. Of course, the seizure burden reduced after the phenobarbital, that is expected. And we saw some changes which we expected in the blood flow and the metabolic component. And Kelly used some very nice analysis to show how the neurovascular coupling and neurometabolic coupling actually changed following seizures and how it recovers following treatment with the phenobarbital, and she presented it in pairs. Now, Magda, who is also here, did some nice work with the ASL. And this picture actually tells you the whole story. So this is one animal, pre-ictal. This is another animal, post-ictal, who received the biocuculin. And the third animal here, he received biocuculin plus phenobarbital. So you can see almost 6 hours after the seizure inductions, the brain had significantly raised perfusion still. And if you treat with the phenobarbital, that reduces dramatically. So these were statistically significant results. Now, during this period, we got some funding from the BRC to look at the brain temperatures. With the MR spectroscopy, you can measure the brain temperature very easily, looking at the change in the water spectra in respect to the metabolites. And we used the NIR spectra, where there is changes in the NIR spectra based on the temperature. And we have shown that the seizures definitely increase your brain temperatures. The group B, who had the biococulin, had a higher temperature at 30 minutes post-seizure inductions compared to the one that received the biococulin plus phenobarbital. So this is very interesting and needs to be explored further. There's a lot of discussion beyond lactate NA that whether we could measure the individual metabolites separately and whether there was any benefit doing that. And there are some methods which needs extended scanning time, but we wanted to do something with the same kind of scanning period without increasing the scanning time. And working with Alan Bainbridge, we used a technical combined reference methodology, and we used individual metabolite estimations. And we could see here the NAA, when we individually measured, actually had significant predictor of outcomes at 2 years in all 3 domains of outcomes. But this was not superior to our lactate NA that we use clinically. So the lactate NA is still our clinical biomarker. Now, I presented that work in PASS 2022, and in the same meeting, the HEAL trial was presented. So it was a nice trial. Their preclinical work, their phase 1 study, their phase 2 study shown really positive outcomes. But when they completed their phase 3 trial, there was no benefit. So we were at a stage where there was still no neuroprotective adjunct beyond hypothermia, which was introduced 2010. So we started talking about, is there any way we can actually start looking at the fetus again with light? This was Donald Peebles' work, and I took these pictures from Volpe's textbook. It's still there. And just by coincidence, this call came in, the Wellcome Leap in Utero call. And I would like to kind of focus here. The abstract deadline, 30th June, abstract feedback sent 15th July, full proposal submission 15th of August. So we submitted our initial abstract. We got a response on 15th of July. Yes, it has been provisionally accepted. You now need to submit the full proposal. And this is a period between mid-July and mid-August where everyone is on holiday. Okay? So we booked a holiday in a village near French Alps. And I woke up every morning before my wife and my daughter wakes up and sitting in a balcony with a cup of coffee trying to prepare this proposal. And after a week, I sent it to my co-investigators. Now, ultimately, we were successful. The idea is great from Wellcome Leap, trying to develop a global network to fight stillbirth. We met every 6 months, and you might see some familiar faces there. And this is what they advertise. This kind of work is hard, but I think we really underestimated what they said about hard. And we got into realizations over the next 3 years. Now, why, as a neonatologist, I jumped into stillbirth? I think the fetal hypoxia is a common factor here, which leads to newborn brain injury and stillbirth. And if you look at the latest NHS resolution report, you will see that it clearly says inadequate fetal monitoring is responsible for 70% cases of avoidable brain injuries in the UK. And if you look at the current assessment tools, we know they are suboptimal. There are multiple Cochrane reviews that shows that. And interestingly, most stillbirths are preventable. These are the current trends. If you look at the UNICEF report, initially over the years, there was a steady decline, but it seems to be plateauing now. And this was the last data available in the UK in 2021, where this is the stillbirth rate, this is the neonatal mortality rate. Now, we had some, the government had some targets by 2025, and we know that we couldn't achieve those targets. So there's a lot to do there. So we started placental nears monitoring. It started as a blue sky project, but I can tell you 3 years down the line, we have progressed significantly. So we started prospect study, and the idea was that we will develop a wearable sensors that will give us non-invasive warning tool, and it will be integrated with the cloud-based machine learning model for prediction. It's easy to say we are going to do that, but there were so many challenges. It's easy to look at a newborn brain or adult brain with near-infrared spectroscopy. But think about placenta. It doesn't have a fixed structure. It's a floppy organ. It can go anywhere. It can go anteriorly, it can go posteriorly, it can go fundal. So there were no specific algorithms or modelings available, organ specific for this organ. And for brain, it's easy because you start from here and in newborn baby, there are very thin skulls, a little bit of skin, and you go straight to brain. But for placenta, you need to go through all the layers from the abdomen, on the abdomen. And it differs in individuals. So there's a lot to work on, and a significant amount of engineering work went in. There's a significant hard work from the clinical team went in as well. Nicole is doing her PhD and is spending time mostly in the antenatal and intrapartum wards to do these studies. So this is her scan. So she's scanning every single participant. And at the moment, we have a catalog of nearly 700 women that has been scanned over the last 3 years. And measuring all the different layers that before reaching the placenta. We started the study with a big time domineers system called Maestros. And you can see here that we were monitoring a lady. Now, after 3 months in the study, the machine stopped working. And we asked the engineers to come and have a look. And they said, okay, the laser is not working. The laser has failed. So how can we replace it? Yes, we can replace it. How much does it cost? 50 grand just to replace a laser. So we thought that's it. But anyway, we went back to the funder and managed to convince the funder to give us another 50 grand to replace the laser. And that was done quickly, and we completed that study. And then Nicole analyzed the data. The idea was to look at what is normal and establish what is normal, because we don't know what is normal. So this is normal placental tissue oxygenation that we can expect over gestation. Here you can see. What was interesting that if you are in the lower level, the chance of falling is more during the pregnancy, which was interesting. And we saw some similar trend in the placental metabolism as well. And we looked at different placental positions, maternal positions, different ethnicities. These were done mainly to kind of gain confidence in our measurements, and it all went well. So the study started in October 1st. So we were told, I think, mid-September 22 that we were successful. We had to start on the 1st October 2022. So within 15 days, we had to start the study. Anyway, so in March 2023, we started the study here. And during the next year, between 23 and 24, we developed these wearable sensor prototype. And then March 24, we brought that prototype to the clinics to start another clinical study. And this time, the focus was a group where there is a possibility of placental insufficiency, so high-risk group. And we started the study in UK and in India. It was easy for us to go and do this study in India because UCL had a collaborations with India, had a MOU, but also Sarah Hillman already had an established relationship with the AIMS team. But there was another reason to choose India. India was the country which was reporting highest number of stillbirth cases in the world year after year. And that's the official report. So unofficially, I'm pretty sure this is much higher than that. So we went to India, we set up a study there on multiple occasions. And if you are India and you are working hard, this is something you definitely need, a cup of tea. So these are some of Nicole's preliminary analysis. So we didn't see much difference between the good and poor outcome based on what we call here is the nearest criteria. So this is a criteria that was established by the Inaugural group to look at globally, not in the high income settings, but both high and low middle income settings for prediction of poor outcome. But when we looked at the actual perinatal outcomes, it seemed to us that there was something that we picked up from the relationship between the oxygen delivery and the metabolism. But if you're working at UCLH, chance of poor outcome is very low. So the number of pregnant participants with poor outcome is low. But this is something interesting. But we didn't actually expect that because these monitoring was in the antenatal period and were quite stable participants. We did a significant work with the advanced research computing team at UCL. This is a work done by Zakaria Zanussi. So we developed a machine learning model which predicts the outcome. And if we only focus on the placental oxygenations, we get almost 80% of balanced accuracy to predict outcome. But if you then take all the information from the superficial layers going up to the placenta, that easily goes up to 90. We are actually trying to understand what that actually means. Now, the funder was quite excited with the progress, and they pushed us to go ahead and work with a third-party company and develop these fully wearable sensor. And we were funded a little bit more to do another study with this. So we just finished collecting data at the end of December, both in India and in UCLH, and we are at the moment trying to analyze that data, and we'll come back to you. Now, in the meantime, we approached NIHR for doing an intrapartum study because LEAP was initially interested in both antepartum and intrapartum, but they focused only on antepartum. But we feel, I think, this technology will have a much bigger impact in the intrapartum period. So we started nearly finishing the MERIT study, and during the recent visit of Keir Starmer to India, there were some new fundings announced, and we were quite lucky to get one of those fundings. So we have now a 2-year funding for a study, a similar study with the intrapartum study in India as well. Now, I've talked a lot about UCL Medical Physics and Engineering Department and our work. And I think one of the key things of these successful collaborations over the years is actually the physical proximity. So whenever we have a problem here, we speak to the engineers and it takes them 6 to 7 minutes to come to UCLH and sort it out. We did a collaboration, 60 years collaboration celebrations earlier last year. Unfortunately, being an organizer, both myself, Ilyas, and also Judith couldn't attend that. 2 of us were had COVID a couple of days before this, and I think Ilyas had to go for another meeting, but it was a very successful meeting, I hear. that is pretty much my journey and so far. But before finishing, I just wanted to share a few more slides. Many of you know that I lost my mother a few months ago. She would have been very proud to be here, but I'm grateful to my team who worked really hard over the last year to continue the study. I'm also grateful to the engineering team and also my co-investigators here in UCLH and in India. And also my colleagues in UCLH. I know this is an old picture. This is a picture taken for the UCLH magazine, and some of my colleagues here have moved on and we have new colleagues. But it's a beautiful unit to work on. And last not but the least is these two human beings tolerate me most. I can say the other way around too. Aprajita, my wife, my friend philosopher misguide since my med school days, and Ahana, my daughter, who, despite our repeated warnings, decided to go into medicine as is now in a third-year medical student. That's all. Thank you. Thank you for coming.
I think you can see that Subha's journey really epitomizes everything that's fantastic about being a clinical academic. So I first met Subha probably back in 2019 when I took over as director. Yeah. And I remember because we were developing his fellowship application, I was supposed to be writing all these letters of support and saying how wonderful he was. And I thought, well, I better go and meet this wonderful person. What is he actually going to do? And then when we started talking, I realized, I remember we first started talking and you were saying, well, I want to monitor oxygen in the baby's brain and how the baby's brain is functioning. And we were thinking, well, you know, it'd be great to do you out of a neonatal job and actually to monitor the baby before it gets out. Can we do this in pregnancy? And it's just fantastic to see the development that you've made, the progress that you've made. I think the other thing to say is that Subha not only got a Wellcome Trust fellowship, he also got a fellowship from the MRC. And he had to make a choice. So he not only got one, but he was awarded two. So it was just absolutely fantastic to get that success. I think what I felt very much working with Subha and the whole team, and that includes the engineers, is it's a lot of fun. I think that's the main thing that's come across. I remember going to the Metabolite exhibition at the Royal Society back in 22, and it was just great to find out what you're all doing. And it's been great to have the team working together. Wellcome Leap has been an interesting experience. I never forget the timeline coming out and going, no. And it was absolutely crazy. But in some ways, they didn't want us to do a fully fledged application. They wanted blue sky thinking. They wanted us to provide some new, exciting ways to prevent stillbirth. And boy, have we done that. I think working with the team, I don't know how, Subha, you've managed to keep it all together and keep smiling while crazy requirements are come from the funding teams, because they are very much driven by blue sky thinking, the funding, the aims. And of all the studies that were funded by Wellcome Leap, I think there are only about 3-4 that are still going strong, and this is one of them. The work that you've been doing is going to absolutely transform care of babies. I'm absolutely convinced of that. And I think it's fantastic, tantamount your knowledge, your curiosity-driven research, your ability to link in with patients, with engineers, with clinicians. I mean, I sort of think of you as an honorary obstetrician. You could probably interpret a CTG as well as I could, because we've had to have these incredibly engaging discussions about who are we going to include in a trial of a device to monitor women who are in labor, who are perhaps at risk of having a stillbirth. So I think you've really shown us the way forward. I personally love working with you. It's always great to come along to the meetings, even though it's incredibly stressful, but you always smile through, and you are such a great leader in the team. So congratulations, Professor Mitra.
Thank you.
Particularly looking forward to meeting your wife and your daughter and your family to find